Hi everyone. So in this video, we're going to work through a Year 12 Pure Maths question from the 2018 AS paper. So part I to the question says, show that x squared minus 8x plus 17 is greater than 0 for all real values of x. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level Maths topics that will come up in your 2027 exams. So now that the 2026 exams have finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018 and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up to the app and you'll be able to access all of these 2027 predictions. Now, with any kind of question like this, where we're trying to show that a quadratic expression is greater than 0, or it could be showing a quadratic expression is less than 0, we're going to use completing the square. And you'll see why in our working in a moment, why completing the square is the best method for a question like this. So what we're going to do is complete the square on the left side. So that gives us x minus 4. So half the x coefficients give you minus 4. Square that. Then subtract the constant in the bracket squared. So subtract 4 squared and then plus 17. So then, of course, this gives us x minus 4 all squared minus 16 plus 17. So then that gives us x minus 4 all squared. And then minus 16 plus 17 is obviously going to be plus 1. So now we need to justify why that thing there is always positive. There are a couple ways you could go about this. I will start with probably the easiest way to go about this to start with, and then I'll show you the other way you can do it later. So what we know is obviously since x is a real value, x is a real number, that means that, of course, x minus 4 is also a real number, obviously, right? So that means that x minus 4 all squared is never negative. Why is that? Well, that's because when you square a real value, you can't get a negative number, okay? Because obviously if you square 5, for example, that gives you 25, that's a positive number. If you square minus 5, that gives you 25 as well, a positive number. When you square negative numbers, you get positive numbers. And when you square 0, so like if x was 4 here, you get 0 squared. Well, 0 squared is obviously 0, that's not negative. So this can't be negative. So let's just say since squaring real numbers never gives a negative. So therefore, that means that this x minus 4 all squared is greater than or equal to 0, because again, it could be 0. Now, what we're doing, obviously, in this question is we're adding 1 to that non-negative number. So we can just say here that obviously 1 is bigger than 0. So therefore, obviously, if you're adding a positive number to a number that can't be negative, then this must also be positive, right? So 1 plus a non-negative number is obviously positive. Plus 1 must be positive. And that's our proof done for the question. Now, there is, as I said, an alternative method. So I'll just explain this down here. So let's just say here, alternative explanation. And with this alternative explanation, we're going to think about this graphically. So we're going to consider the graph y equals, and then I'm going to use the completed square form there. So x minus 4 all squared plus 1. Now, hopefully you remember from your quadratics knowledge that when you complete the square, that gives you the turning point. So the turning point for this quadratic, hopefully you can see, will be 4 across and 1 up. Okay, so the negative of whatever's there, and then 1, that's your y value for the turning point. Now, in terms of the shape of the graph, we know that the x squared coefficient was 1. X squared coefficient was 1. So if we go back to the start of the question, you can see obviously here the x squared coefficient there is a 1. So that means that this is positive. So therefore the shape of the quadratic is going to be a U shape, okay, a parabola U shape because of the positive x squared coefficient. So therefore what you can say is that the sketch of the graph looks something like this. So let's put x there, y there, 4 there, 1 there. So the turning point is there. It's going to be a U shape. So clearly y values are always positive. So therefore, this quadratic expression x squared minus 8x plus 17 is always bigger than 0. So that's an alternative way to explain it. A little bit longer than the first method. So personally, I would just stick with this real number explanation that we talked about. But if you want to do this graphically, you can. Just another quick interjection. If you are currently doing Edexcel A-level Maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website. And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you know you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. Great, so that's part 1 done. Let's go to part 2. So we've got a quotation here. If I add 3 to a number and square the sum, the result is greater than the square of the original number. State giving a reason if the above statement is always true, sometimes true, or never true. Sorry, never true, not never true, never true. So if we add 3 to a number, I mean, let's just call this number x. Okay, let's just call that x. Let's just say that x is some real number. We're going to add 3 to it, and then we're going to square it. And we're comparing that against the original number, which was x squared. So the square of the original number. Let's write this down properly here. So what we're doing is we're comparing. So the original number plus 3 all squared versus the original number squared. That's what we're looking at doing here. So what you could do in a question like this, where you have to show that something is always true or sometimes true or never true, like with this one, you could just plug in some random values, using your calculator or just using your mental maths, and just seeing if something works, right? Or just seeing if there's a pattern or, using your intuition to see if this is always going to be true or never true or sometimes true. So, you could sub in, for example, a random number like x equals, let's go with like 5. If you did that, you have 5 plus 3 squared versus 5 squared. So obviously this is going to give you 8 squared versus 5 squared. So obviously this gives you 64 versus 25. So you can say that in this case, this means that x plus 3 all squared is greater than x squared. But in another example, you may want to sub in something like, let's say, -4, x equals -4. So in this case, you would have -4 plus 3 squared versus -4 all squared. Now, this would give you on the left side a -1 squared versus the -4 squared. So you end up on the left side with 1, because -1 times -1 is 1, versus 16, because -4 times -4 is 16. So in this case, we can actually see that the x plus 3 all squared is actually less than the x squared this time. So therefore, we can conclude, the conclusion with the question is the original statement is sometimes true. So statement is sometimes true. So that would be fine as an answer to this one. That'd be fine for the 2 marks because it was a 2-mark question, I think, wasn't it? Yeah, 2 marks. So you can just do, plug in some examples, see what works, see what doesn't work, and then come to the conclusion that it is sometimes true. If you want to do this question in a more algebraic way, what we could do, let's try and fit this in here, is again, we're comparing. So comparing x plus 3 squared versus x squared. So this is equivalent to comparing x squared plus 6x plus 9. I've just expanded the brackets versus x squared. Now, what you can do now is you can remove the x squared on both sides of that kind of comparison. So that then gives you x squared plus 9 versus 0. So then the question becomes, is x squared plus 9 always bigger than 0, or always less than 0, or sometimes bigger than 0, sometimes less than 0? And what you can just simply do to explain this is you could sketch the graph of y equals 6x plus 9. Okay, so the graph of y equals 6x plus 9, if we try and fit this in there, you've got a y-intercept of 9. You've got some x-intercept down there. If you just set the 6x plus 9 equal to 0, you will get an x-intercept of -9 over 6, which would then simplify to -3 over 2, right? So you've got an x value or roots there of -3 over 2. You've got your line like that. So you can say that clearly if x is greater than -3 over 2, then it means that the x plus 3 squared is greater than x squared. But if x is less than that -3 over 2, then actually the x plus 3 all squared would be less than x squared. So therefore, again, the statement is sometimes true. So if you want a more algebraic proof with this question, you can do this kind of method I've done there. However, that is not required in this example. You can just plug in 2 random numbers and just see if you get the result. Or, well, let me be a bit more specific. Don't plug in 2 random values. Plug in a value that works and plug in a value that doesn't work. Okay, so you can just, plug in random numbers in the calculator, find something that works, find something that doesn't work. But if you are finding that you're spending a really long time doing that in the exam, you may just want to go and do this algebraic method that I've done there. If you've got any questions on this example, do let me know in the comments below. But hopefully everything we've gone through there does make sense.